Right, we're going to talk about the asymptotes for this function. As you know that I will just discuss the about the vertical asymptotes and horizontal asymptote. So at first I want to discuss about the vertical asymptotes for this function here. Is there any vertical asymptotes or not? If this is a rational function, right, we always focus on the numerator, the denominator, where the denominator cannot be 0, because if this denominator will be 0, then there are no output here, will be undefined, right? But for this case here, x squared plus 16 is always positive, right? It's always positive. Means that it won't be 0. X squared plus 16 will always positive and will not be 0. For any value of x that you are using, you have 1, -1, -4, -4 square. You're getting 16 plus 16. 4 square, 16 plus 16. They will be always positive, right? So it means for these cases here, the domain x can be accept any value. The domain of f in this case is -infinity to infinity. So it means that if you can accept all the value of x, so it means that of course, there are no vertical asymptotes for these cases here. So I can conclude that no vertical asymptote. But there may be a horizontal asymptote. So now we consider horizontal asymptote. Alright? Horizontal asymptotes. So for horizontal asymptote, we have to consider the limits at infinity, right? The limits at infinity means at positive infinity and at negative infinity here. So for this function, I'm going for positive infinity and negative infinity. So over x squared means that you're finding the limits at positive infinity and negative infinity for this function here. So to evaluate this type of limits, what's the techniques here is that the cases here will be, if you substitute infinity here, you are getting infinity divided by infinity here. So as I tell you, I can know the answer is 1. Why? Because at infinity square means that a very big number, a very big number. So as you square, let's say if you square plus with 16, this number is so big and this not the value, these two values will be the same, right? But this is just plus a 16, plus 16. So it means that it maybe you will produce 1 0 0 0 0 0 0 0 0, and down here you have 1 0 0 0 0 0, another 16, right? You kaya, dia ada banyak kosong. Kosong dia pun sama banyak. Tapi dia ada lebih 16 ringgit. So bila you bahagi dua ini, you will dapat hampir sama saja, kan? Kekayaan mereka hampir sama. Hanya dia lebih 16 ringgit. Hampir sama means 1, right? If you compare, you're getting 1, right? So this is the concept of limits, but you cannot explain using this way, right? So you have to be mathematically calculate. So how? Very simple. So as I tell you that you divide by the highest power of the denominator here, right? The highest degree here. So will be divided by x squared over x squared plus with 16 over x squared over x squared. So then you will have limit as x approaching positive infinity, where this you were getting 1 plus with 16 over x to the power of 2, right? As x approaching infinity, right, this value here will become very big. As the constant divided by a value that very big, you are approaching 0. Approaching 0, not 0, approaching 0. So we can assume it to be 0. 1 over 1 is 1. So we're getting the limits here 1. So positive infinity, you're getting 1. Means that this is your horizontal asymptote, right? With one side of one of the limits at infinity, either positive or negative, you're getting a value. That value must be a horizontal asymptote. Okay, we can further verify we can further check, is it have two possible horizontal asymptote? So the method applied will be the same. Case of infinity over infinity. So you will apply the same thing here, divide by highest degree of the denominator, and you will get 1 over 1 plus 16 over x squared. This one approaching 0, and we're getting 1. So means that y equals to 1 is a horizontal asymptote for this function. Alright? Horizontal asymptotes of this function. So there is only one asymptote here, which is the horizontal asymptote, and there are no vertical asymptote here. So I'm going to show you the graph for this function. Alright, let's look at, you know that there are no vertical asymptotes, right? So there is a horizontal asymptotes here. So let's look at how the graph goes. Very simple, you can predict the graph here. So sketch the graph. So you have y and you have x, right? So then you know that there is only one horizontal asymptote, y equals to 1, right? So y equals to 1. So y equals to 1. So y equals to 1 is a horizontal asymptote. So as x approaching positive infinity and negative infinity, it will be approaching 1, right? So let's see, is this graph having a y-intercept or not? Y-intercept. Y-intercept here means x0, right? So you substitute 0 here, 0 square over 0 plus 16, you have 0. So it means that 0 will be your intersection point here. So now, as the graph going to positive infinity, means approaching positive, very big, the value of x getting bigger and bigger. The curve will be approaching 1, right? Approaching 1. So it means that there is a curve here. It's approaching 1, very near to 1, but cannot touch 1. So here also, when you go to negative infinity, the curve also will be approaching 1, right? Approaching means they won't intersect. Alright, so this will be the curve here. So of course, I know why there is a point here, because this is a stationary point here, which you haven't learned yet. But I just wanted to focus. Why is it approaching 1 here? Because from the limits, you know, the graph will be approaching 1 from positive infinity and negative infinity. Alright, so this will be the curve of this function.